Hi guys, Mr. McIntyre here. Moving on to surds. If we take the examples, root 36 and root 144, so the square root of 36 and the square root of 144 give you exact values of 6 and 12, okay? So those exact values, or the roots that have exact values, are called rational. Any root that does not have an exact value, and where there's a square root, then it ends up in a decimal, is something that's called irrational, or what we call it is a surd. Okay, so root 2, as you can see from the screen, gives you approximately 1.41. The cube root of 21, approximately 2.76. Because they have decimal values that could carry on, they're not an exact value, so they're not rational. Okay, and therefore they're surds. Okay, now in simple terms, though, we're looking at surds as just something that's got a square root over it. Okay, and there's times where we can take advantage and leave the rational numbers in a surd form to allow us to simplify an irrational number, or to simplify a surd. The first two rules are shown there in the box. Rule 1, any fraction that's inside of a square root can be split up into two individual square roots. So again, we use letters to help signify that. It's a little bit easier when looking at numbers and examples. So if we have the square root of a over b is the same as the square root of a over the square root of b. And rule 2, in the same way, if we have the square root of ab, now I do want to say that what we've got here, we've seen before that AB is the same as A times B. So the square root of A times B is the same as the square root of A times the square root of B. And those two rules can help us simplify surds. And that's effectively what we're going to move on to now with the first set of examples. Okay guys, before we actually start to tackle the surds, we need to be 100% certain on our square numbers, working with the square root of these square numbers and understanding exactly where they come from. That will tie very closely into the factors of any given number, and if we can use the square numbers to be included as one of the factors. So just to remind you of the table on the left here is the table of square numbers. This is something that we should be pretty familiar with at the moment. So any number on the left hand side, the x value is multiplied by itself to get the x squared value. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on and so forth. So if we go all the way down and we take 8 times 8, then that's 64. Now, we also need to be familiar with the fact that on the reverse, the square root of 64 is therefore 8. So it's working in the opposite direction. So any number on the right-hand side, if we take the square root, goes to the number on the left-hand side. You'll see there the root of 36 is 6. The square root of 100 is 10. The square root of 144 is 12, and so on. So it's working with these square roots and the square numbers that will absolutely put us in a strong position when we go through the rest of the surds and the indices topic. So 8 times 8 is 64. So what we're thinking at the top is the square root of 64. What number do we multiply by itself to get 64? And that is 8. Okay. Now, factors. We need to look also at reminding ourselves of the work we've done with factors. What is a factor? Factor is a number that can divide into another number without a remainder, or it's sometimes easier to think of pairs of factors, and they're two numbers that multiply together to result in a particular number. Now, that wordy expressions and explanations are not always too clear. If we take factors of 50 as our example, what we would be looking for is, I think when you were in first year, you would have started with a list of 1 and 50, because 1 times 50 is 50, then you would check, can I multiply 2 by anything? 2 by 25, 3, 4, nothing we can multiply by, 5 times 10, and then at this stage, you would be checking the numbers between 5 and 10, so there's nothing in there that's going to give us 50 as a value. So ultimately what we're looking at these pairs, 1 and 50, 2 and 25, and 5 and 10. And as we get better at that, we're more likely to be writing those pairs next to each other, 1 and 50, 2 and 25, and 5 and 10. Okay, so these are numbers that multiply together to give that resultant number of 50. Now, why? You're probably thinking, why are we looking at factors? And in this case, it's because when we come to simplify a surd, what we want to do is we want to split that surd into factors. Okay, so that's ultimately what rule 2, which was the square root of a over, so square root of ab, that is ab, a would be factor 1, b would be factor 2. So we're going to need to do that if we want to split them. Now, if we take this example, factors of 50, if we're looking through those pairs, 1 and 50, neither of the 1 nor the 50 are square numbers. They're not on this list on the left-hand side. Okay, 2 and 25, well, yes, we've got 25 is on that list, so that might be helpful. That's what we're looking for. We're looking for square numbers. 5 and 10, there aren't any. So ultimately what I would be saying here is that the pair of factors that we want to focus on are 2 and 25. Now that's probably something that's going to make more sense when we actually look at the practicalities of simplifying a surd, but I'll go through another example just to be sure. Okay, this time if we look at the factors of 32, if we were to look at 1 and 32 as a pair of factors, neither of those two are square numbers, not going to help us. 2 and 16, and hopefully you'll recognize 16 is a square number, so that's probably going to be something that's very helpful. 3, we can't do 3 times, there's nothing, 32 is not in the 3 times table. 4 and 8 would give us 32. Can't multiply 5, 6, or 7 to get 32. So we have 3 pairs of factors here, and the 1 and the 32, neither of them are square numbers. The 2 is not, but the 16 is. So that is a number that sits on the right-hand side in this table. The 4 and the 8 doesn't help us. So that's why I would be saying at the end of this, the ones we want to focus on are the 2 and the 16. So just a little quick reminder of, first of all, what factors are, numbers that multiply to give another number, and how we want to focus on the pairs of factors. Okay, looking at the surd root 18. So if we were to take, first of all, the square root of 18, that's not a square number in itself. So that's going to be an irrational number. So it's a surd. So what we want to do is we want to try and use the stuff we've learned about the factors of 18 and the fact that we want to look at the square numbers. Is there a square number involved in the factors of 18 that will help us split this up? So first of all, before we tackle this exact question, just a little reminder of rule 2, like I'd mentioned to you before. So we have rule 2 was the square root of a times b equals square root of a times the square root of b. Now, to be a little clearer, what that means is we want to take this square root of ab and first of all split that into the individual values. Okay, so that AB could be one number. Okay, what we want to do is to split it into 2 factors that multiply together to give that number. And then once we have that, we can split them out into individual roots. And you notice that the square roots are separated here. We need to look now then at the factors of 18, because if we're going to have 2 numbers under the square root, we need to look at what 2 numbers multiply to get 18. So if we start with the factors of 18, we have 1 and 18, 2 and 9, and 3 and 6. What we now need to do is to consider what pair of factors is the best we can use to simplify the square root of 18. So naturally, we can create a combination of these two numbers and split root 18 up. And what I want to do is I want to go through and assess those options. So if we take the square root of 18, as I've shown you previously, what we're looking to do is first of all split that into two numbers that multiply together. That would be our factors, and then therefore that will allow us to split into two individual roots like this. Okay, so if we have the root of 18, if we want to check the sets of factors, we'll start with 1 and 18 and see if that helps us. So if I take the square root of 18 and take the factors 18 of 18, which are 1 and 18, that would give us the square root of 18. That would mean we would split up into root 1 and root 18. Now, hopefully you'll recognize that this doesn't actually help us. This root 1 is just going to be the square root of 1 is 1. 1 times the square root of 18. The square root of 18 cannot be done, cannot be simplified. It's irrational. So that we end up back in the same position as we were before. So that combination, if we're looking at that alone, this one here, 1 and 18, has to go. That does not work. Okay, so let's now look at 2 and 9. So here we have a couple of options. We've got 2 and 9, so that means we can split this up into the square root of 2 and the square root of 9. Now, hopefully you'll recognize that the square root of 9, that's going to give us a rational number. That's going to give us 3. Okay, so what I would suggest when we do this, as we get better at it, is when you come to split into the two square roots, that you would try, if you can, if you recognize that there's going to be a square number, in this case 9, I would encourage you to lead with the 9. So the square root of 2 times the square root of 9 is the same as the square root of 9 times the square root of 2. And the reason for that is simply that we have, or we're able to there, deal with the square root of 9 as a 3. So the square root of 9 from our square numbers, what number do we multiply by itself to get 9? That's going to be 3 times root 2. And we don't need the times when it comes to surds, so we'll just write 3 root 2. And that would be simplified. Okay, now that's the situation where we have our 2 and our 9. That works. So we can take a simplified version of the square root of 18. We're able to take square root of 9 times square root of 2. So that we can go through it, we can check 3 and 6 just to show you that that's going to fail. There isn't a square number in there. So we'll have a look at 3 and 6 as well. Okay, if we split the 18 into the factors 3 and 6, you can see we'll split that up. That's root 3 and root 6. And neither of these are going to be rational numbers, so we can't simplify. It doesn't help us. It can be split. It doesn't help us make anything smaller or simplify. You would notice that you are also, or it's possible that we could write root 6, root 3, depending on the order, but that's not going to help us. Those do not help us by giving us a rational number and a sub. So as you can see from the previous example, the 2 and the 9 is what helps us, and we got 3 root 2 as our simplified answer. Okay, full worked examples. We'll try and avoid the extra workings on the side, and we don't need to trial all the possible factor options. So the square root of 20, we want to be able to split 20 into factors. So the factors of 20, 1 and 20, 2 and 10, and 4 and 5. Now, rather than going through the options like I did in the previous slide, hopefully what we're looking to identify here is a pair that includes a square number. This one does not. 1 and 20, no square number. 2 and 10, no square number. 4 and 5, we've got 4 as a square number, and that's going to help us when it comes to splitting this root 20 up. Okay, so as I mentioned before, we have two options. We've got the square root of 20. We can write this as the square root of 4 times 5. Okay, or we can write that as the square root of 5 times 4. The reason I lead with the 4 in this instance is that the 4 is the square number. Okay, now this step in the middle here will eventually come away. We won't need to split it with them both underneath the square root. So what you'll skip to is the square root of 4 times the square root of 5, or sometimes we will just simply write that as root 4, root 5 next to each other. Okay, we know that if there's nothing in between two items, it's a multiplication, right? So root 4, we know the square root of 4 is what number do we multiply to, by itself to get 4? That can change to a 2. 2 root 5, like I said before, that's the same as 2 times root 5, but we don't tend to put the times in there. So the simplified surd is 2 root 5. Example B, we'll go a little shorter again this time. We're looking at the factors of 48. Now, we don't need to go through this every time, but just for the purpose of understanding where these numbers come from, we'll look at 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. Okay, so what we're looking to do is identify the largest square number. In this instance, the largest square number is 16. So that would mean the pairs that we want to look at, that we want to look at is 3 and 16. None of the others involve a square number that's going to help us simplify this surd. So we're going to select 3 and 16. And like I'd said before, when we move on to actually splitting this up, we don't need to write the square root of 16 times 3. You will hopefully get to a stage where you're confident enough to write the square root of 16 times the square root of 3, or indeed root 16 root 3, and that will allow us to change the square root of 16 to the value that we know as 4 and 4 root 3, and that's a simplified surd. Okay, now a couple of things there. Why did I lead with 16? I led with the 16 because at the end here it's going to be a lot easier for us to have the square number at the front. Okay, if we don't have the square number at the front and at the end we end up with root 3 times 4, then that sometimes can open the door for a mistake to change that to root 12, which would be wrong. Okay, not what you want to be doing. So tend to lead with the square number in the first instance. Okay, the third example, we have the square root of 12 over 75. So what we're going to need to do is actually split these individually. Okay, so the first thing from rule 1 is that we can change that full square root into two individual square roots of the square root of 12 over the square root of 75. And that was from rule 1 right at the beginning, where we have a over b is the same as root a over root b. Okay, so that's the first rule. That allows us to now look at individually the square root of 12 and the square root of 75. What we'll need to do is we'll need to simplify both of those individual surds. So if we look at the factors of 12, in the first instance we've got 1 and 12, 2 and 6, and 3 and 4. Hopefully you'll recognize now that we've got 3 and 4, and that gives us a square root of 4. Okay, so that would be the factors of 12. The factors of 75, looking at 1 and 75, 3 and 25, and straight away you'll recognize that 25 as a square number is going to help us here. Now the convenient thing you'll hopefully see too is that they both have a 3 in there. So that 3 is going to help us no end when it comes to simplifying at the end. Okay, so individually, let's have a look at this again. We're going to take the square root of 12, square root of 12 over the square root of 75. So if we select the 3 and 4, I'm going to have the square root of 4 at the start because that's the square number. Equally, in the 3 and the 25, we're going to take the 25 to start us because that's the square number. So square root of 25 over the square root times the square root of 3. So the combination here, 4 times 3 is 12, 25 times 3 is 75. They both need to have square numbers, square roots over them. And from here, we can simplify the individual square roots. So the square root of 4 is 2. And we've still got root 3. The square root of 25 is 5. We've still got the root 3. And one final thing, once we have multiplying by the same value at the top, common factor here and at the bottom is root 3. So we can remove that root 3 and leaves us with just 2 over 5. And that's because we've got 2 times the square root of 3, 5 times the square root of 3. So there's a common factor of the square root of 3. That's not going to happen all the time. You might end up with 2 different values for your roots. But in this particular example, we're able to cancel out the roots and we're left with just 2/5. Okay, you saw in the last example that root splitting the square root of when there's fractions, we can do that individually. There is the odd occasion and you'll see one here, where actually dealing with the fraction itself first can help you avoid that. So if instead of splitting this up into the square root of 16 over the square root of 4, we could deal with the division. Okay, and to do that, we need to recognize that 16 over 4 like this is a divide. So 16 divided by 4 within that root would just take us to 4, and the square root of 4 is 2. However, if we were to take the longer root, like you've seen in the previous slide, we could still arrive at the same answer by taking individual roots, the square root of 16 over the square root of 4. We end up with 4 over 2. And again, that's a divide. So 4 divided by 2 is 2. And ultimately, we arrive at the same answer. It's just an extra little bit of notation for you to recognize. Sometimes this way is quicker.